hate Platts right now. I know. Fall 2020. There you go. I should have borrowed the penis suplex shirt. Good to go, or? All right, I guess we'll get started. Welcome to modern password cracking as a methodology, also called hashes, scattered, smothered, covered, for all you Waffle House fans. Who am I? I am not Joshua Platts. He unfortunately couldn't be here. He's my co-presenter for this talk. He's done a lot of the research with me. So there's some info on him. I am Lee Wangenheim. I'm a security consultant at Optiv. I work on the attack and pen side. I hack things for fun as well as a job. I just happen to get paid for it. I've been in the InfoSec game for about 5 years. Prior to that, I was in the military. Along with Josh, we kind of run the cracking program over at Optiv. So we've been doing a lot of enterprise password assessments, and that's kind of what this talk is focused on, where we're not looking at, one or two hashes that we got from Responder. We're looking at an entire enterprise, like an entire 80 dump or NTDS, where we're going to dump all of your user hashes and recover as many as we can. Optiv is the world's leading security solutions integrator. We do cyber operations, threat management, and we are currently looking to hire a senior consultant on the attack and pen side. So if you are looking to join an awesome team, come see me or visit that website. Why does this matter? So here's some examples from real world stuff that we've seen in the last few days, or last few weeks. So you can see we cracked something using RockU. That's the default word list that comes bundled in with Kali. We actually used a different word list initially, but then when we realized how weak the password is, we hit it with GrrCON just to show. That was a domain admin account that we were able to pop using GrrCON. We find all the time on engagements, we have blank passwords, we have default passwords, fall 2019 Bane as a password, common credentials, all of that. That's going to be our way in a lot of times on an engagement, especially if you have over about 1,000 employees in your company. I guarantee you one of them is using fall 2019 right now, and all I need is one. So what kind of hardware are we using at Optiv? So we kind of broke the budget a little bit. We'll get to this in a little bit, but we got the budget to get 320 GPUs. That's really the important number there. All the rest is kind of fluff. We have moved on to using cloud computing as well as using our own internal tools. So really the game has changed with AWS and other cloud computing services as far as the amount of hashes that we can do. Last year when we were preparing this talk, we were shooting for about 2 terahashes, which in TLM, which is about 2 trillion guesses per second. As you'll see later on, we went a little bit above that and hit 22 terahashes, so 22 trillion guesses per second, allowing us to brute force the entire 8-character key space in under 10 minutes. So if you have an 8-character password policy, it is dead. So you guys want to do some cracking, right? I'm sure anybody that's familiar with the OSTP knows about John the Ripper. John the Ripper and rainbow tables, those used to be the way to do it. CPU cracking is really not worth it anymore. It's kind of gone the way of a lot of, like the Bitcoin mining and things like that. We've moved on to GPU cracking. We now, like if we're on site and we have our laptops and we don't have, viable internet, you can use your laptop. We do have an in-house mining rig, actually 2 in-house mining rigs. But then we're also using a lot of cloud stuff. It is scalable in the cloud, infinitely scalable. AWS is happy to take your credit card and happy to let you continue to pay for more GPUs. Rainbow tables come up a lot in talks. They're kind of dead. The only reason that they're in here is people still like to use them. However, you'll see it's actually faster than looking up stuff on a rainbow table to just brute force it through Hashcat. So, cracking in the cloud. In 2017, AWS released their GPU boxes. This was a game changer for us. We are a consulting firm. Everything kind of comes down to the bottom line, especially when we're building stuff out to clients. So we bill everything by the gigahash hour. The reason that's important is because this number is linear. So as long as you just continue to add more GPUs, that number doesn't change. So it's no longer a matter of how long do you want to take to crack a password, it's how much money do you want to spend. Because I can run 320 GPUs at, $200 for the hour and crack your 8-character password in an hour, or I could spend that same $300 or $200 and run, a smaller cracker for a month. So it's no longer a matter of how much time is it going to take. It's a matter of how much money it's going to take. And so we'll get into that later and show how, you really need to step up your complexity. We do have on-site, or in our labs, we do have a cracker that has 6 1080 GPUs. Those are not the TIs. We bought them just before the TI came out. However, in the future, we are looking to upgrade to a box that has 8 2080 TIs, which should give us a much more capable machine to go along with our AWS instances. So in September of 2019, so very, very recently, they released a brand new box here on AWS. It's still a little bit expensive compared to building our own. However, again, it's infinitely scalable, and it's a little bit cheaper than the P3s. The T4 GPUs give us 143 gigahash per second, and that's for each instance. And so we can continue to add more and more instances as we move forward. We did try this, and there was an issue with the benchmarking where AWS, because we were sharing resources with other people on the same box, they weren't giving us the 100% of the GPU that they said they were giving us. So the benchmarks that they were claiming to have were actually lower than what we were seeing in real-world applications. This didn't really make us too happy, so we started looking at other options. And quite frankly, at this moment, you can't beat AWS for price if you're looking at cloud. There are like a few things like supercomputers through universities and stuff, but you get into some interesting legal issues with that. Again, if you're doing client work. I'm going to go over some of the terms that we use, just so we're all kind of speaking the same language. So a mask. A mask is the makeup of a word broken into its character set. A good example of this is fall 2019, starting with a capital letter, would be an uppercase letter followed by 3 lowercase letters and then 4 digits, right? The reason this is important is because if I'm using a mask to brute force your password, that mask is going to allow me to significantly reduce the amount of characters that I'm trying to brute force against. So I'm guessing against common patterns that I see. So if a company says we have a 12-character password and we enforce complexity with digits and special characters, I say, oh, that's great. And then I put a mask in that starts with a capital letter and then has a bunch of lowercase letters, trails with digits, and trails with a special character. And now I'm only really brute forcing probably about 8 characters again. So I've reduced that that time to crack your passwords from multiple weeks to months to about 3 days to go through your 12-character key set. Now I'm not going to get 100% of those. But again, if I've got a company with 22,000 users and you say I've got, this complexity, we see that, just due to like the way humans' psychology works, they'll start with the uppercase letter and then they finish off with their digits and their special characters. So that's a really important thing, because masks help you crack things a lot faster. A hybrid attack is where you take a word list and then you append a brute force either to you either prepend or append a brute force to it. So you would take, say, the company name, so optive, right? And I would either have 3 to 4 characters before and 3 to 4 characters after optive, and I would brute force any combination of things with 3 characters before optive or 3 characters after optive, which would help me, again, attack your passwords a lot quicker because those 4 characters or 5 characters in octave, I'm not having to brute force against. So I'm significantly reducing the GPU cycles. The difference between a word list and a password dump, this one comes up a lot. So a word list is something that we use to generate potential passwords using rules. So a word list is going to be dictionary words. I use this a lot if I'm based out of Columbus, Ohio. So if I'm going up against a company in Columbus, Ohio, I'm going to use Ohio State. I'm going to use Buckeyes. I'm going to use Columbus. I'm going to use the company name as a word list. Whereas a password dump is going to be like actual passwords that were cracked, and then we are feeding those into the cracker to try against it. So that would be your fall 2019 Bane and things like that. The difference is when you apply rules to a word list, they will modify themselves into what looks like the password dump, but a password dump will never come back and change itself back to just a dictionary word. So it's important to kind of make that distinction. So if you're using rules with your password attacks, you're probably going to want to use a word list. And we can get into like really deep details on word lists, but using common dictionary words, we've got a script that will actually, you can feed common music lyrics and movie quotes and things like that. We had one guy that told us that there was no way we could ever crack his 28-character password, and imagine his surprise when we came back with, yeah, we found it. It's one ring to rule them all. So he thought he was really secure because that's a really long password, right? But we have this script that we feed, common movie stuff in, and through some OSINT, we found out that he was like a huge Lord of the Rings fan. So we were like, well, let's try Lord of the Rings. And the script will actually pull out like long sentences or larger chunks of things and you can set it to grab as many words as you want. And then, the reason word lists are really effective, everyone's familiar with the XKCD thing, right? The horse, battery, tree, staple thing. Well, if I'm using a word list, I can put a rule in to take the top 5,000 most common words in the English language and just start creating different word lists out of that, and then try those as passwords. So passphrases are still stronger because it's still going to take me a longer time, but they're still not quite as secure as just going with like a more random thing. All right, so what kind of tools are we using? This is a great tool, a great quote, right? If your only tool is a hammer, every problem looks like a nail. So in our kit, we use Hashcat, which is a hammer. Hashtopolis is a new tool that we're using internally. It is an open source tool. You can grab it off of GitHub. All it is kind of like an orchestration engine for Hashcat. What it does is it allows you to stand up multiple different nodes and tie them all together, essentially creating a supercomputer, which is running Hashcat jobs on every one of those computers. This is how we're able to integrate all of those 400 or 320 GPUs together through AWS. We're able to feed those all through Hashcat, and then Hashtopolis then chunks all of those jobs up, sends them all to the different Hashcat workers, and allows it to crack simultaneously across that entire space. Cool is a pretty interesting tool. It's great if you're kind of lost or if you're on site and you're doing like WPA stuff. It will scrape a website and generate a word list out of that website. So it'll find, company names and like their core values and things like that. I don't use it that much, to be honest, but it's kind of one of those, like, it's in the bag if I need it. PW Tools is a suite of tools that Josh Platts wrote that kind of help generate a lot of these word lists, help generate some of the stuff. That is available on his GitHub. Hash ID is great if you get a random hash and you have no idea what it is. It's not the best tool though, and honestly, if you get a random hash and you don't know what it is, the best thing is just start looking up the service and kind of seeing if you can find any information on their source code or things like that. Obviously, if you're running Responder or something, you're going to get like net NTLM or things like that. PW Spy is a tool that I wrote, and I'll include a link to that. It's on my GitHub. If anyone's familiar with Pipple, Pipple is an amazing tool that does post-analysis of password cracking, and it'll do things like find common root words, find the longest password that you cracked, find the shortest password that you cracked, generate different masks and things for you. Unfortunately, we found some errors in Pipple. So we started doing some manual analysis on some of our stuff, and found out that it's not really being maintained too much anymore, and we didn't see the results that we wanted out of Pipple, so I started writing our own tool. It's kind of still a work in progress, but what it'll do is it's got different modules that you can turn on and off, and you're able to go in and do your post analysis, and it will spit out a full readout, and it'll say, this is the most common root word that I found. So if they're using winter a lot, or if they're using the company name a lot, you'll see in plain text that password. It will also identify any weak passwords that were recovered. So if any passwords have no special characters or no numbers, you can pull those out to highlight, especially if a company swears up and down that they have 12 character and enforced 4x4 complexity, and then you find, I don't know, Frank as a password, all in lowercase, which has happened on gigs, because some executive got an exception to the rule for passwords and has never changed his password. So it will pull those out. The other great thing about Password Spy is it will create masks for you. So if you've already recovered, say, 50% of a company's passwords, and you're kind of trying to go for like that extra mile, Password Spy will create masks for you that you can then feed back into Hashcat to help you recover the rest. All right, so Hashcat, it's the de facto standard. It supports pretty much every hash algorithm out there. It replaced John the Ripper. Hashcat is using GPU cracking. It's able to do many, many more calculations per second than a GPU ever would. The thing with Hashcat, there's like one zip file that I've had to use John the Ripper on in the last 2 years because it wasn't supported by Hashcat. So it's really easy to set up and integrate with other tools. There's a lot of cool like orchestration things and different scripts and wrappers and stuff that you can feed around it. Also on Hashcat, on their Wikipedia, they have a great example hashes. So instead of trying to run through hash ID, if you get a random hash on engagement, you can pull up their example hashes and kind of see if it fits any of their hashes. Hash topless I kind of covered already. It is the wrapper for Hashcat. So all it does is it just manages agents and jobs and word lists. So you feed it the word list, you feed it the rules and all of that, and then it kind of farms those out to a bunch of different Hashcat binaries distributed across. It's very easy. It's a PHP written tool. We are using it internally, but only for our larger enterprise password assessments. So this isn't something we're using, if you're running Responder on a gig and you get a couple hashes and you're trying to crack it. This is for a company dropped, their entire 20,000 user hash list to us and said, get whatever you can. It is distributed cracking made easy. There are a few limitations that we're not too happy with. For one, it doesn't support SSL, which is problematic if you're trying to keep things secure. Cool. Crawls websites for words. You can set it up for a length and how deep it's going to go. It's really great for WPA hacking, but I wouldn't really recommend using it for much else. So that is actually Josh's cat named Hashcat. I feel obligated to he loves his Hashcat. So this is where you can find his password tools. And it's got a couple of different things. Some of that has been kind of ported over into PW Spy as well. This is what a typical hash ID output is going to look like. As you can see, it's not super helpful. You get this random hash on a gig, you put it into hash ID, and it's like, I don't know, it might be one of these 15 different things that nobody uses anymore. PW Spy I covered. That's where you can find the link. So it's just, super easy to spell, Wangen, PW Spy. All right, so techniques. What are we doing when we get that 20,000 hash dump, and how are we going after these guys? So what's the best way to crack a hash? That's a really loaded question. What's the best way to run Nmap, right? It really depends on what I'm going after. Am I going after one or two domain admin accounts, or am I going after an entire user population? What kind of algorithm are you trying to crack? NTLM, I can crack, as I said, the entire 8-character key space. Even not using our distributed box, I can do the entire 8-character key space in about 4 days on our in-house crackers. WPA2, you try and brute force the entire 8-character key space, and it's going to take you years. So, you kind of have to know what kind of hash you're going after and tailor your stuff to that. How do you look? Where do you get hashes? You can either hash dump local accounts, you can use Mimikatz, web apps, Responder, Shadow is great if you can find a Shadow file, comp files, all the usual places. A lot of times you'll find, especially in a Unix environment, developers love to put environment variables with their passwords in it so that they can like upload stuff to SQL and things a lot easier. So if you just start grokking through their their bash RC and things like that, you can actually find either their full password or hashes. So this talk kind of stems from when we started doing these password audits. So we started doing these where it's like a massive amount of hashes that we were going after for, as opposed to just like one or two. And our clients wanted us to kind of provide some sort of an analysis based on what we're seeing, patterns that we see, and we really needed to create a repeatable process that I can hand off to any of our other consultants and say, here's this, and then so we know that our clients are getting the same exact kind of look at their passwords. So it's very, very analysis based. I spend most of my time on these password audits after the crackers have done running, just looking at the passwords that we've cracked and trying to figure out why somebody created a password that way. Another thing I always do is I look at a password that I cracked, and I'm trying to figure out how we cracked that password. What was the rule? How can I tweak maybe a rule, tweak a word list, things like that. One thing that came up in a previous talk that was an amazing question was, have you ever made a word list with common misspelling words? And we hadn't thought about that, but now that's something that we do. So we have that in one of our main word lists that we use in-house because, just didn't even think of it, right? So we're looking for easy wins. We're looking for quick spikes and things like that. This is not something to undertake if you're trying to run this off of your desktop with like one GPU. You need a heavy hitting cracking rig, either through AWS, cloud setup, or just building a full robust cracking rig. So what do we use for our quick wins? We use proprietary word lists, which are kind of tailored from a lot of experience over the years with our teams. And as we create new word lists and new rules, we build those in. We then will modify those rules or modify those word lists using rules. And then we do a lot of loopback attacks. So what a loopback attack will do is it takes passwords that have already cracked in your current task, and then it will send it back into the rules and the word lists and use those passwords to then try and crack other passwords in the environment. The masks I kind of touched on, if you say you have a, 12 character complexity, I'm going to start with an uppercase and trail with digits and special characters, and I'll probably get like another 30% of your passwords. This is what it looks like when we execute our methodology. This is cracked over time. So you can see the duration in minutes. Within about 10 minutes, this is an actual from a live gig where I think this was 12,000 passwords or hashes that they gave us to crack. We ended up cracking like 97% of them. And you can see the vast majority were cracked within the first 10 minutes of the assessment. That was using proprietary word lists, previously known dumps, and no rules. Then we started adding rules, and you can kind of see it takes a little bit longer. And towards the end, we're getting to like diminishing returns, right? We're running these tasks for a very long time and getting very low return. But we had time left on the gig, so we let the crackers go after it. If you've done this before, how do you help yourself in the future, right? Pop files keep a historical record of your cracked hashes. Depending on your client, they might not want that, right? They might not want you storing their passwords. So sometimes we will create a new pop file just for a particular client. And also, I usually will create a pop file out of a new crack, or a new engagement, just so I have clean data to work with. But a pop file will take is what Hashcat will use, and it will run those hashes through previous engagements, and it will see if you've already cracked that hash, and then it just won't spend GPU cycles on it. The problem with pop files is you can get bloat really, really quickly. So with bloat, you start getting into the rainbow table problem, where you're spending so much time doing a directory lookup on searching through a text file, which is all a pop file is, that you're actually spending more time than it would take to just crack that hash again. So every once in a while, it's good to clean your pop file out. We had an incident where somebody dumped the entire, when LinkedIn was popped, they dumped their entire pop file into our pop file. And so it was looking up like 4-character passwords, which we never see in our environments. So we had to clean those out of our pop file and basically start fresh. I kind of have my own little cheat list of masks that I use when I'm running. As you start to see more and more common masks, just start building them and keeping them in your back pocket to run against Hashcat. You will not see a live demo. However, I do have a quick video of this is kind of hash topless in action using the is this not showing? There we go. So this is using Hashtopolis. As you can see, it's got a very friendly user interface. What we did is we generated some passwords that we knew would not get cracked by the innate character brute force. We threw that hash into Hashtopolis and got the credit card out, called up AWS and said, we want as many GPUs as you will give us. We had to get special permission through AWS because they actually will limit the number of GPU boxes you can get with a new account. So we said, that's fine. So you can see all the different agents. So right now we don't have any agents. This is how easy it is to add. We created a little script that you feed in, and this will just reach back to our lab, connect to Hashtopolis as the as the engine, and then this is where we said run that script on every one of these instances. This is not my personal AWS account, by the way. This is Josh's. He has that kind of money. I don't. So now you can see we've added them all there. You can see all of our different P2 instances, or all of our different instances are running. They've got Hashcat up. Now we go back to our agents and refresh. And you can see we have now added pretty much infinite power to our password cracking rig. Just like that. Total elapsed time is 4 minutes, and we've added 320 GPUs to our cracking rig for relatively low cost. This rig, as far as we can tell, is the second fastest in the civilian world, and we are now competing with state-level actors when we've combined this. They obviously will not release their numbers, but there is a particular agency that's around, centered around national security that possibly has a faster cracker, but we were not able to confirm that. So we turn it on. And then you can see as Hashtopolis works, it's just sending different jobs to all of these different agents across its entire network. And now the fun begins. This is our speed over time. We were shooting for 2 terahashes per second. As you can see, this is about 22 terahashes per second. So 22 trillion guesses per second against an NTLM network. We let it run for 5 minutes, and it completely brute forced the entire 8-character key space. And you can see it's pretty stable and runs the entire way. So you can see the evolution of our goals. This was just a year ago. We were shooting for maybe we can get to 1 terahash. Within a year, we were hitting 22 terahashes. You know, a year from now, we might be able to double that. Password cracking is going to go cloud-based. It's going to become much more easy to do for just about anybody that's got a credit card. If you think you have a strong password policy, I would highly recommend you start looking over it, because we got the 8-character in under a couple minutes. We can get to another, you know, place. This is not our slide. This is actually from Brutalis. They are another company that does, they focus pretty much specifically on password crackers. They were able to hit 31 terahashes on their stuff. So this is kind of showing where it's going. NTLM, all the way up to 9 characters is under 5 minutes on their rig. 10 characters, oh, I'm sorry, 8 characters is under 5 minutes. 10 characters is 5 hours. You know, they're starting to approach where they're able to brute force your entire key space. Up to about 10 characters is a reasonable time for NTLM. That's 3 weeks, 0 days. So how important is the information that you're storing behind NTLM hashes? You know, there are people out there that can crack it in 3 weeks. As you can see, just adding 1 more character takes that 3-week time span and pushes it to 5 years. So going to an 11-character password increases that time. The problem is, again, using masks and using the psychology that we have, we can shorten that down, so I'm only brute forcing against 8 characters, and I'm back to where I started. So what do you do to train your users? You teach them not to start their passwords with a capital letter and trail with digits. Put the capital letter in the middle. Don't use common words. There's a great website out there called Password Chart. I think it's .net or .org. If you just Google password chart. And what that does is it creates a grid with the letters A through Z on it, and you would just remember a code word, and below each letter A through Z has 5 random characters. And so you would create a code, print this chart out, set it at your desk, and remember your code word, like optive. And then you would go to O, and then use those 5 characters below. And then when it comes time to change your password, you can regenerate that chart and then use your same password or passkey. You know, obviously the danger there is if somebody guesses your passkey, you're screwed, but it is more secure than, you know, using fall 2019 in your password. I know NIST is going to the no password reset thing. We're kind of back and forth on that. I'm kind of, if there's no reason to force a password change, I would say you don't need to force it as long as you have a strong password policy, because that's where you start seeing in the 3-month password resets, that's where you start seeing people having weak passwords, because if I have to change my password every 90 days, I need something that I can remember when I type it in at the beginning of the day. So I'm going to use fall 2019, or I'm just going to iterate, you know, like Optive 1, Optive 2, Optive 3 every time that I create a new password. And so that's something that you want to kind of take into account. All right. I know that I kind of ran through this a little fast. I apologize. Like I said, Josh was supposed to be here and go much more into the AWS stuff because that's much more his side. But does anybody have any questions? Yes, sir. So ASICs is an interesting question. The problem is nobody's building ASICs for password cracking at this time. So it's if somebody came out with an ASIC, we would probably look at it, but it's not a big enough business. So it's not Bitcoin mining where an ASIC would be. That's something we're looking at. We are also, we've been talking to a couple other like supercomputing sites to maybe rent some time on their boxes as well. So. What was your AWS bill? So I think for that, it was about $500 for the 10 minutes that we ran it. So. It's expensive, but again, that $500 I could spend over 3 months and get the same results. So it's no longer a matter of how much you want. It's now how much you want to spend, not how much time you want. Yes. Yeah, so a company wants to test and see if their password policies are strong or if they have a user education problem with weak passwords. So what they'll do is they'll dump their entire NTDS database, give us those hashes and say, crack as many as you can and tell us what you see. So we do it for like a financial institution that might have like a really sensitive information. So we'll look at their entire user base and say, we cracked this. And up to and including their domain admin accounts. And domain admin accounts are no more secure from what I've seen. I cracked one the other day that the password was God mode in 2019. So, yes.
How do you feel about password strength meters, and is there one you recommend?
Password strength meters. That's a good question. They're all kind of using their own proprietary blend there. I use a password manager. So I'm using, I have one very long password that I've memorized that I use to log into that. And then I'm just generating passwords out of that that's using the... Yeah, so yeah, the websites that you go on and you type your password in, I personally don't trust them because I'm not going to type a password that I'm going to use into some random web form because I don't know what's on the other side of that. I think it's a good idea if you're trying to educate your user base and you were showing like fall 2019 as a weak password, but I could generate a 12-character password that has all the complexity that would meet and show up as a strong password, but using my masks, I'm going to crack that a lot faster. So, they're not able to do kind of that human analysis. So it's kind of that bridge between, machine learning and humans actually taking a look at things. Yes. So currently, we use the NVIDIA suite, only because that's what we have available to us. And because of the way their chips are built, I apologize, I'm not a CUDA programmer, but they are able to do the password cracking algorithms better than the AMD chips at this point. So adaptive, when we are speaking with our clients, we recommend 12 characters and 4x4 complexity. So we want to see special characters and numbers and upper and lower case. Right, we disagree with NIST on that, especially since what we're seeing is we're able to take those, 4-word pass phrases and crack those just as easy as we are. Yeah. Now, it does take us longer to crack the passphrases, and it's a little bit slower and things like that, but we're still able to get those. Yes. No. Those are, if there's a pattern of letters on a keyboard, I guarantee you it's in one of my word lists. Our proprietary word lists are about 3 gigabytes each. and that's a text file. So, yes.
One comment is, I think an aspect of that discrimination is often overlooked is the advice they're giving about like turn off the predicated on the password filter, not invisible.
Yes. Right, and that's a good point. I'll repeat it. So the gentleman here said the NIST recommendations is based on using a password filter. So that is often overlooked, and that's a very good point because you know, a lot of companies aren't supporting the password filtering side of the house, but they're enforcing some of the not resetting and not having special characters like that. So that's a very good point. Yeah. Absolutely. So we do start looking at historical data. You know, we'll say, you know, last time we were able to crack this many passwords. Let's see, you know, are you guys getting better, right? And then, you know, we're consultants, so we try and sit down with our client and have those conversations about, you know, why are you guys having so many bad passwords? And it really, like certain industries, like the financial industry, for whatever reason, has like the worst passwords. But that's just, you know, what we see. And so we'll go through and we're like, well, we know you guys have bad passwords, but we try and figure out the why behind that so that we can help them get more secure. Right. It is a moving target, but we measure them against the current technology. So, because measuring them against my password cracker from last year isn't going to matter because, you know, we've moved on to a 22 terahash box, right? So, yeah, like you guys might have gotten a little bit better, but you didn't get better enough. Mm-hmm. Sir.
Your passwords are becoming easier to crack. Is MFA at a desktop level or an application level in a PC level?
Absolutely. You know, always use MFA if you can.
Even just like logging into your PC.
Right. Yeah. You know, like logging into your PC, like YubiKey is a great one. I don't personally have a YubiKey because I'm terrified of losing it. I know the previous speaker mentioned having chips. I also have chips in my hand, and I'm probably going to start using those as MFA. So when I'm near my computer, I can just log in with that. So. Sir.
So, does your program, or are there any programs out there that account for foreign words, or
it depends. So we do have a couple of word lists for foreign clients. So we have a couple of clients that have international offices, and we'll try and build word lists depending on like common foreign words, but that's kind of an ad hoc thing. So I know that there are a couple out there. We don't do a lot of business in regions where we would need non-English words, but it is a good point. What we're going after is the low-hanging fruit, really. And then, you know, as you saw that chart of the cracked over time, once you start like flattening out at the end, we're just really kind of like grasping for anything at that point. So we're running a task for 2 days that might only get us 1 or 2 passwords at that point, but we've already cracked the other 93% of your passwords. So we're not going to I'll never get the ones where it's like you hold the alt and like 254, you know, like the weird ASCII stuff and things like that. Like if you've got that as your password, like awesome. Emojis are really weird in passwords, but I find that those can get weird if you're trying to enter them into like an actual web form, because sometimes they do it weird. So, sir.
Basically about that, I was curious if you extended ASCII at all. You see that anywhere?
I don't.
As a child, I figured out how to put it in smiley face.
Yeah, if you're doing that, that's not in my word list, and good, you beat me. But you know, the person in the financial side that's using Fall 2019 for his password. use to get in on your box, run responder, and, you know, have all my fun.
You've answered a lifelong question.
Yep.
Does your client have any concern with uploading their hashes to AWS?
That's why we're only using it for select clients right now. Yeah, we're kind of still in the building out those phases. Well, it really depends on the client. You know, you sit down and you have that conversation and you're like, these are the steps we're going to take to secure your hashes. And, you know, we can, you know, SFTP stuff back and forth between AWS. Like, AWS by itself is not insecure. It's when you don't set it up correctly that it becomes insecure. So, we're trying to do it the best way we can. It's really kind of a judgment call on the client. So, and it's what they want from an engagement, right? So if they want us to run our full, like, 22 terahashes against it, or do they want us to just use our in-house crackers where everything is secure and behind that, you know, behind our firewalls? So, sir. We're full GPU at this point. As I said earlier, if somebody makes an ASIC for password cracking, we'll be in on it. But it's just the money isn't there. You know, if I called up a chip manufacturer and said I want an ASIC to crack NTLM, plus, you know, we're cracking many different algorithms, whereas an ASIC, like for a Bitcoin, for example, is only dealing with the particular Bitcoin hash. So I would need a separate chip to go after each different kind of hash. So the most obvious would be like NTLM, but even that, you know, a lot of times we're cracking responder hashes that's NTLM v2, so that's not even going to work. So the GPU is just kind of, it's cheap and easy. So, sir.
Have you looked at other architectures like distributed list across the unused CPU cycles of virtualized environments? You've got a big VM farm, lots of
We've looked at that. It's not cost effective. CPU cracking, just even in like we've joked, like, oh, hey, this client has like 200,000 employees. We could just turn all their desktops into a giant cracking rig at night, right? But I mean, all you're going to do is run up in a really expensive electric bill for something that I can accomplish with GPU cracking in a day. Well, so. All right. Yep.
These masking rules give you the ability to crack a 12-character password generally like 80%, 90% of the time.
Yeah.
Is there a length of password right now that even your masking rules don't really help you very much?
I mean, it really depends. I'll make a mask up to like 20 characters if I have to. So like if I'm kind of at the end of an engagement and I have, you know, 5% of the hashes to go after, I'll just start throwing random masks at it, and say like, give me the first 4 characters as lowercase and then finish it off with that. So then I'm shortening the amount of brute force. So when you put the masks in Hashcat, there's like a little language. So you do like question mark and then, A for any character in the 96 character, key space, or like U for the uppercase, L for lowercase. So instead of brute forcing against 96 characters, I'm only brute forcing those 26 characters. And so I'll kind of step that down, so that I'm significantly reducing the GPU cycles. And again, we're not going to catch everything, but, the longer and more complex you can make a password, the better off you're going to be. No password is 100% guaranteed to not be crackable. But it's just kind of, at that point, it's kind of luck on my part if I put the right mask in to crack you.